Hello, my name is Mary Mozingo, and I am an instructor with the Global Navigation Nautical team in Redlands, California. I want to welcome you all to the What's New in PLTS for ArcGIS Nautical Solution 9.2 training seminar. For those of you who are unfamiliar with the acronym, PLTS stands for Production Line Toolset. In this training seminar, I will introduce you to the PLTS Nautical Solution extension and demonstrate how these tools can help with chart and S57 data creation. The topics presented in this training seminar are: what is the PLTS Nautical Solution? Then I will cover nautical charting capabilities with the solution, and we will end with the ENC data production tools and functionality. Each of these topics will be followed by a software demonstration and review. Also, I will go over a list of frequently asked questions regarding the nautical solution at the end of this seminar. Let's begin with our first topic. What is the PLTS Nautical Solution? PLTS, again, stands for Production Line Toolset. It is an extension to the ArcGIS desktop product. So what is the PLTS Nautical Solution, and how does it fit into the production process? The purpose of PLTS is to help with the overall production process within ArcGIS. PLTS extends the ArcGIS desktop for production interface. With PLTS, you have tools that help to manage the production workflow. There are also tools available to help streamline data creation and maintenance. These tools are designed to provide an efficient editing and attribution environment. Another component of PLTS has been specifically created for performing data review. This includes visual and automated review tools as well as documentation of errors. PLTS also has tools designed to enhance the cartographic production process, including tools that help you build and manage a map series or a map book. As we start to explore the PLTS extension, you will see that there are two tiers to the product. The first tier is known as PLTS Foundation. This is the base tier, providing you with all the workflow management, data production, data review, and cartography tools. The components of PLTS Foundation are job tracking for ArcGIS, also referred to as JTX. This is the workflow management component. The foundation tools. Don't let this name confuse you. This component of the foundation tier contains the tools that streamline the editing and attribution environment. The GIS Data Reviewer contains tools for performing data QC. Checking the data quality is an important part of the production process, and the GIS Data Reviewer provides a complete review environment. Finally, the Map Production System Atlas, or MPS Atlas, is your cartographic aid. MPS Atlas contains the tools and functionality for producing a series of high-quality cartographic maps. The second tier of the PLTS product is termed the Solution tier. A solution provides users with database, production tools, and cartographic templates that are geared towards meeting the standards of your chosen industry. In this training seminar, we will be focusing on the PLTS Nautical Solution. The PLTS Nautical Solution provides efficient management of nautical data and products. The data and products supported are both for civilian and defense nautical standards. The solution and its data models are enterprise-enabled. The solution is enterprise scalable and flexible to provide, for instance, one central database for both charting and S57 data. As an extension, it is built on ArcGIS Desktop, and in addition can also be used on the ArcGIS Server platform. With the release of the PLTS for ArcGIS Nautical Solution 9.2, several products are supported. With the VPF standard, or Vector Product Format, the Digital Nautical Chart, or DNC production, is fully supported. This format is mainly used by the United States National Geospatial Intelligence Agency, or NGA for short. S57 is the International Hydrographic Organization, or IHO, transfer standard for digital hydrographic data. The Nautical Solution supports several S57 product specifications. ENC, or Electronic Nautical Chart Production, is supported out of the box. AML, also known as Additional Military Layers, and IENC, or Inland Electronic Navigation Charts, are supported S57 products as well. However, AML and IENC require some configuration of the existing nautical data model. Several nautical chart product standards are also supported with the nautical solution. Again, the IHO specification for INT1 International 1 is supported through provided symbols in the INT1 style file provided with the solution, as well as label expressions for abbreviations. The INT2 borders, graduation, grids, and linear scales are supported with XML files used in conjunction with the PLTS Grid Manager. The combined support with the nautical solution of INT1 and INT2 specifications also supports INT3 as well. For the domestic US, there are also symbols and tools to support nautical chart production for civilian, commercial, and defense chart products, such as NOAA and US Department of Defense. Functionality within MPS Atlas enables the creation of map books. This can be especially useful for inland waterways, such as navigating along a portion of the Mississippi River. Many of these products are newly supported with the PLTS for ArcGIS Nautical Solution at 9.2. The S57 and IHO chart production is the main focus of what's new in the nautical solution and what we'll be discussing in this seminar. In addition to the foundation components, the nautical solution includes geodatabase templates for ENC, DNC, and charting models. There are several geoprocessing tools that are included with the nautical solution that provide for more efficient data production. A sample data CD is provided with the solution, including DNC, ENC, and nautical chart sample data and MXDs. Nautical cartographic tools and elements are included, such as the magnetic calculator and PLTS Grid Manager. The symbology and grids provided with the nautical solution are from the IHO INT1, INT2, and INT3 specifications. S57 data production capabilities and editing tools make up another large portion of what's new in the nautical solution at 9.2. Unit conversion of S57 and chart data for depth and height fields is automated through the use of rules. For instance, the U.S. produces ENC data in both meters, which is specified by the IHO standard, and feet, which U.S. mariners traditionally use. Scale-in, or minimum scale, is the scale below which a feature is no longer visible on a ship's electronic chart display and information system. The assignment of scale-in values is based on initial configuration. The management of sounding groups in S57 data is necessary in order to reduce the file size, as soundings are the most abundant feature that is collected. Soundings are grouped based on similar attribution, and there are several tools to help us select sounding groups, create groups, as well as appending to existing sounding groups. Let's go to our first software demonstration. What I'm going to do is activate the PLTS extension and explore the Foundation Tools editing and attribution environment. I have some ENC data here from Florida, and what we want to do is make some edits. Now, the first thing that I need to do with PLTS is to ensure that the extension is activated. I'll do that just like any other extension from ArcGIS by going to Tools and Extensions. We will see here each of the individual components that I've just talked about with the PLTS Nautical Solution. We have the Nautical Solution extension as well as MPS Atlas, GIS Data Reviewer, and the PLTS Foundation tools for editing and attribution. Now that I know that my extensions are activated, I can start using PLTS. Let's first take a look at the ArcMap interface with PLTS installed and activated. One thing you'll notice right away are the additional tabs in the table of contents. The PLTS selection and PLTS target tabs are very useful for feature attribution and feature creation. PLTS also has several toolbars for more efficient data creation and maintenance. Some tools you'll notice are the same as ArcGIS core functions, but they reduce the number of clicks with the mouse. For instance, I've already started my edit session with a single click of the PLTS Start Edit Session button, which is on the PLTS Editing and Environment toolbar as shown here. The edit session has already been started, so let's take a look at how I can create features. First, I need to set my target layer. With the PLTS Target tab, this is accomplished with a single click. Notice how the Target tab lists all of the feature classes that are loaded into ArcMap in our Display tab in the table of contents. I'm going to set my target here to create a buoy special purpose feature. If I add this feature right now, you'll notice that the attribution associated with it is default, and all of these values are set to null. But I remember that I also have loaded a favorites database. A PLTS favorites database contains pre-attributed combinations that allow for more efficient feature creation. By expanding the buoy special purpose subtype, I can see my favorite that has been created for me already. This is actually shared by a coworker. These are saved within a geodatabase and can be distributed throughout your organization. If I select on this favorite, in this lower portion within the PLTS Target tab, I can see the attributes that are associated with it. This happens to be a pillar buoy, which is not what I want to add. While the PLTS Target tab is used to select the target for features that I want to create, the PLTS Selection tab is used to view the attribution of already existing and selected features. So from the PLTS Selection tab, I see a tree view of my currently selected feature. Happens to be this beacon right here. In the lower part of the tab, we again see the fields and attribution for this selected feature. You'll notice that some of the fields are bold, while others are grayed out, and some appear normal. These bold fields designate the use of mandatory attributes and provide a visual cue to anyone editing the attribution of this data. I'm going to remove the attribution for the mandatory attribute CATLAM, or category of lateral mark field. Changing this to null, you'll notice that this field value has changed, and we now see that it has a blue tint, and the checkbox next to it is checked. To commit this attribution change to the feature, I need to click the Apply button. Remembering that this is a mandatory attribute that I have now changed to null, I expect to see this error message popping up. It ran certain conditions that have already been pre-configured with this model, and it lets me know that the category of lateral mark is a mandatory attribute and that it must not be null. Okay, I noticed that the attribute here and the checkbox are still blue and checked on, meaning that these changes have not been made to my feature yet. I'll change this back to the value of 1, which it originally was. It's still blue and the box is checked. Now when I click Apply, it performs the same validation, but it does not find that there is a mandatory attribute count to null. Now that this value has been changed, I've applied it and it's ran through and passed the conditions that are set up to check for it. it has now applied my attributes, which are valid to the features. If I'd like to add this new attribute combination to my favorites database, I can simply right-click on it and say Create Favorite. My input favorite name is going to be a pile, port hand, lateral mark. Now when I go back to my PLTS target tab and go to my beacon P lateral beacon subtype, I notice that there's a new favorite underneath it for my port hand lateral mark. You've now seen the PLTS interface in ArcMap and a sampling of some of the efficient editing tools that are available. I'm going to save my edits. And let's review what we've covered so far. When it comes right down to it, PLTS really is a combination of geodatabase creation, data extraction and attribution, quality control and data review, cartographic production, and workflow management tools. With the Nautical solution, we build on top of this foundation with nautical and hydrographic industry-specific data models, validation, and symbology. Let's continue with a look at nautical charting with the PLTS Nautical solution. The nautical chart production process begins with cartographic editing, such as generalization, edge matching, and so on. Each chart can be stored in an individual geodatabase. The underlying nautical data is contained within its own feature dataset. The grids and borders are contained within the same geodatabase, but in a separate feature dataset. They all are corresponding to the same nautical chart. If a source diagram is required for the chart, it also has its own feature dataset. And in this example, we see one layout, which is actually comprised of data from 3 separate geodatabases, one for each panel, that have been combined in ArcMap as separate data frames to form one hard copy nautical chart output. When a chart edition is ready for QC or perhaps publication, there are many different formats available to export from ArcMap into. We will discuss these shortly. Symbolizing nautical data with the PLTS Nautical solution is aided by the INT1 style file included with the solution. Here we see examples of INT1 symbols that are included in that style file. The symbols are displayed by representation rules within the geodatabase. In addition, INT1 contains specifications for labeling features, such as lights. Label expressions have been created and included with the nautical solution according to INT1 spec. And with any cartographic production, masking is a very important part and is included within the solution as well. The geoprocessing framework for nautical charting includes tools for calculating the world magnetic model, as well as generating light sectors, lines, and areas representing those light sectors based off of original point features, as well as aligning top marks to their respective navigational aids. Once our data has been symbolized, we need to add grids and borders. The INT2 IHO specifications for grids and borders are supplied with the nautical solution. They include the 14 scale range dependent formats, although most hydrographic agencies will take those formats and customize them to their own versions of INT2, which of course is easily done with the nautical solution. The grids and borders are managed and created with the PLTS Grid Manager. The INT2 borders and grids are delivered and included with the nautical solution as XML files. The grids and borders can be created over a specified chart extent using the PLTS Grid Manager wizard. Here we see an example of grids and borders that were created. The Grid Manager uses those XML files and the wizard to create our grids and borders which are a series of feature classes within our geodatabase. Because they are a series of feature classes, all we need to do to customize them is to start an edit session and use the designer tool to customize those to our individual hydrographic agencies' proprietary border styles. Once our data has been symbolized and we've done our cartographic editing, our grids and borders have been added, we need to be concerned about our page layout. That includes our guidelines as well as snapping to them, any graphics that need to be included, for instance, specific text on the chart number or chart name, logos. For here, we see an example of the National Geospatial Intelligence Agency, or NGA, chart logo, as well as the NOAA chart logo. We also have the ability to add specific graphics such as neat lines around our data as well. In addition, on our page layout, there are certain surround elements or marginalia that need to be added. For instance, we see here an example of a tide table. We've used something called the Graphic Table Elements tool that's included with PLTS, or GTE tool. It looks similar to Excel with its columns and rows that allow us to customize and create individual tide tables or scale bars to be included with our nautical charts. You can see here that this is an example of a somewhat complex tide table, and it's easily created with the GTE tool. We can not only create these, add them to individual charts, we can load them from saved tide tables with the GTE tool as well. Once we've symbolized our data, we've also added our grids and borders, and we've laid out our page. Next thing that we'd like to do is export. There are several options available for exporting from ArcGIS. For instance, if we would like to export as a vector, we can export to EPS files, PDFs. We can make color separations of spot Pantone C spot color, as well as processing the colors into CMYK. To export rasters, we have the ability to export TIFFs, GeoTIFFs, as well as color separations and separated TIFFs. Here we see an example of exporting color separated TIFFs of our chart. In the second software demonstration, I will expose the compass rose representation rules and correspondingly use the World Magnetic Model Calculator to rotate the compass rose to magnetic north. I'm already in an edit session, and I'd like to switch my view to an existing compass rose. So one very important element of a nautical chart is the compass rose, which includes designating true north, pointing here, as well as magnetic north within a specific location. True north is where all of the longitude lines meet at the North Pole of Earth, whereas magnetic north can vary by your location, altitude, and the day of the year. The magnetic field is constantly shifting over time, and the angular difference between true north and magnetic north is the declination, which we will see depicted on a nautical chart with a compass rose. In this example here, our compass rose is pointing magnetic north, is actually pointing towards true north because we have not made our World Magnetic Model calculations yet. I have here the same ENC S57 base data from Florida, which I want to make a chart of. You'll see again how this compass rose only points to true north. I'm going to use the magnetic calculator to populate the declination to a field called the val-mag, or value of magnetic pole field, for the magnetic P feature class. The representation for the compass rose has multiple layers. Let's take a look at these properties right now. For magnetic P, I want to look at the properties for each of these features within the layer. We're looking at one specific magnetic P point right now and its corresponding representation. So here's our representation. And I notice that it has different layers, which we can see the marker styles here. And I happen to know that this layer is that outermost circle that we see pointing to true north, whereas this layer here, I happen to know, is the inner circle, which is supposed to point towards magnetic north. Because this symbol is actually divided into these separate layers, I can choose to rotate the magnetic north circle layer individual from the true north pointing circle. I can set the angle of rotation to a specific field in my database, and I see here that the angle of rotation is on my val mag field. This is exactly what I want to have happen. And I'll clear my selected features. Now I could do the complex calculations myself to determine the magnetic declination. However, nautical charts can have more than one compass rose per chart, and for anyone managing several charts, this is a very time-consuming task. I'm going to open the Magnetic Calculator GP tool now through Arc Toolbox. It is located within the PLTS Foundation Tools Magnetic Toolset. My magnetic calculator is here. Again, the magnetic declination has many determining factors. So first I'm going to put in my XY location, which is my point feature class. Magnetic P is my input feature class. Altitude is another determining factor. The linear units listed here refer to the units in the altitude field. Now I'm gathering data for a nautical chart. The data is always based on nautical charts at sea level, thus my altitude is going to be 0. And because I'm providing an altitude, I need to provide a linear unit, which I know if I did have an altitude other than 0, it would be in meters. Now that we know our XY location as well as the altitude, we need to input a date. The date must be between the years of January 1st, 2005 and December 31st, 2010. I'm going to use today's date. In this example, I'd also like to populate this calculated value to that val mag field that I referred to earlier, which I'm going to select here from the pull-down list. So the magnetic declination of features at these XY locations in this feature class at an altitude of 0 meters on today's date will be calculated into the val mag field. Now once I click OK, I want you to watch the compass rose very carefully. So the calculations are going to be computed, and what you'll see here is a slight rotation of the compass rose. It's automatically rotating to the correct number of calculated degrees of declination that we've calculated with our magnetic calculator. I'm actually going to stop and save my edits. So now that you've seen the use of representations for the compass rose and the functionality of the magnetic calculator, let's review what we've covered so far. Core ArcGIS and PLTS tools are both used for our feature or cartographic editing in our nautical chart production. The PLTS Grid Manager allows us to create grids from the INT2 supplied XML files that are included with the PLTS Nautical solution. We're also able to efficiently create surround elements or marginalia, such as tide tables. And we can export our hard copy charts once they're created to several different export formats that are available. Now that we've already seen nautical charting with the solution, let's talk about S57 ENC data production. S57 data is managed in several ways with the nautical solution. The S57 ENC files, or 000 files, are imported into the geodatabase. Once we have that S57 data imported with the S57 data importer into the geodatabase, we need to manage our primitives and topology within the geodatabase. The primitives that I'm talking about here are a link between the S57 data and how it's stored and how we manage data in the geodatabase. For instance, if I have a light point in the geodatabase, it's represented in S57 data as a node. And if it's not connected to anything, it's an isolated node. However, if I add a pier to extend down into my water that connects to that node, that light, then that isolated node light would actually change to a connected node when I run the update primitives tool. Updating the primitives and keeping those in sync in the geodatabase is very important in our data management of S57 data process. We also have included topology rules. These are included with the nautical ENC schema and are predefined from the existing S58 ENC validation standard that the IHO provides. Once we import our data into the geodatabase, manage it within the geodatabase itself, adding features, changing them, modifying them, we can produce ENC, EN, and ER files by exporting from the geodatabase. The S57 exporter supports both new additions, EN files, as well as updates or ER files. When we talk about managing our data, it's important to look at some of the editing tools that are included with the Nautical solution. One of the most important editing tools is the S57 Edit extension. This isn't actually a tool that you see on a toolbar, and it's not represented by a tool button. It operates behind the scenes as we're editing our data. It helps us to maintain specific S57 relationships within our data. And it also auto-populates certain mandatory fields like LNAME or long name, which is a unique identifier for each feature. And when I say unique identifier, the IHO specifies that it must be unique to all features that are captured in ENC in the world. It's very important for us to be able to auto-populate that field correctly. Another example of an editing tool within the Nautical solution for editing ENC or S57 data is the Relationship Manager, which allows us to create, manage, and control complex S57 object relationships. Here we see an example of the Relationship Manager dialog. It lists in a tree view all of the collections, master-slave relationships, and multiple representations that we have within our current data extent. We'll see an example of this in the software demonstration later on. There are also sounding tools included as well. We have the ability to select certain soundings from an existing sounding group selected soundings, as well as appending existing soundings to existing groups. The management of soundings is very important, again, because those are our most abundant feature on our ENC or chart data. The grouping of those saves on our S57 file size later on. In addition to editing tools, we also have automated feature creation tools. For instance, there are two geoprocessing tools that are included with the Nautical toolbox in the S57 toolset. They are Generate Depth Area tool, as well as Generate Linear Depth Areas tool. Something else that allows us to automatically create features, aside from the GP tools, is a new tool called the Feature Builder. This feature builder is extremely important for the Nautical solution for geodesic feature creation. In this example here, we see that we're able to create a line of constant bearing or a great circle within our Nautical data set. It's important also to notice all of the other types of functions that we can use to create features. The inputs located here as the coordinates and the azimuth distance, etc., that are needed, they dynamically change based on the functions that are selected here. The feature builder can be used for many different types of creation of complex features such as geodesics, loxodromes, lines of constant bearing. In this final software demonstration, I will be editing ENC data and creating a collection relationship. You'll notice here that I'm still editing the same Florida ENC data. I'll go to my Relationship Manager bookmark here. I am editing the same S57 ENC cell, and notice that it is also the same data that my nautical chart in the last demonstration was derived from. The nautical charting ENC, AML, and IENC products, as well as charting, are from the same schema. In order to create a collection in my ENC data, I need to first be in an edit session, which I am. The Relationship Manager tool is on the PLTS Nautical toolbar. I'm going to go to add this toolbar right now, and I'd like you to notice how many PLTS Nautical toolbars you have included with the solution. The PLTS Nautical toolbar is the one that I'm interested in right now. Here we see the Relationship Manager tool. It helps us to maintain two types of relationships between objects. There are hierarchical relationships and peer-to-peer relationships. The hierarchical relationships have designated master and slave features, meaning that one is dependent or hierarchical above the other. In peer-to-peer relationships, no feature's existence is dependent on one another. And the collections are considered to have a type of peer-to-peer relationship that can be grouped into two different object classes, aggregations or associations. I'm going to create a collection aggregation relationship right now. First, let me move this dialog so that I can select the features that are going to participate in my relationship. I should have 4 features here selected. If I go to my PLTS selection tab, I can see that I do have 4 features in fact selected. The 4 features are 2 beacons and 2 navigation lines. Together, as a collection, these features combine to form a recommended track. What this means is, as a mariner on board your ship, they're going to see these 2 beacons in a line, and they will steer their ship along this path so that as they're moving forward, they see the beacons in line and know that as long as they see them in line, they're following what is referred to as a recommended path to help them enter a narrow channel. In the Relationship Manager, I'm going to right-click my collection and say that I wanted to create the collection. This is where it asks me if I'm creating an aggregation of features or association of features. I've already determined from the S57 spec that in creating a recommended track, I'm creating an aggregation collection. Then once I click OK, a new aggregation collection will be created. We can see it in the tree view of the Relationship Manager. If I move this again, clear my selected features, I can actually add all of these to my selected set. So now we see that we have the original 4 features created, as well as an additional feature object known as a collection object. Because this collection object has been newly created, combining or having a link between all of these new features, I can see a little bit about how the edit extension is actually working behind the scenes. It said that this is the editor name that has recently added this feature, the date and time that it was created as well, the last modified. So today, May 15th. And the L name or long name has already been automatically generated as a random number for this feature, in addition to the name and the dataset name of the corresponding cell that this is included in has also been automatically generated for us. So you've now seen the Relationship Manager and how it's used to create a collection relationship. Let's review what we've covered for ENC production so far. With the Nautical solution, we have many tools for efficient ENC S57 data production. We can manage our S57 data into and out of and within the geodatabase by use of import-export. In addition, there are many editing tools working behind the scenes, as well as tools we can interact with. The edit extension and the relationship manager being two examples of those, as well as our automated feature creation abilities with GP tools and the feature builder tool. I'd like to take a minute now at the end of this seminar to go over some of the frequently asked questions that I've gotten in relation to the PLTS Nautical solution. For instance, is the provided INT1 symbology customizable for individual hydrographic agencies? This is a really good question, and the answer is yes. All of the style files that are included with the INT1.style can be customized, meaning that you can take what we've given you as a kind of jumping off point and create your own customized styles. This is especially useful as many hydrographic agencies have their own proprietary style that's based in part on the INT1 IHO style. My suggestion to you before customizing your INT1 style file is to make a backup copy of it first, though. Another question is, what is the NIS? The Nautical Information System, or NIS, is a type of centralized database and workflow approach for the production of ENC, IANC, AML, and chart products. I mentioned this before, but the schema for the NIS is also the same schema that is used for ENCs, charts, AML, and IENC. This is all based off of S57 schema. So we have here our enterprise geodatabase, our NIS, where all of our edits and geometry are maintained. We make a replica of this, or a copy, that goes out to produce our product instances, or our geodatabases. Here we have an ENC Florida cell, a California Florida cell of ENC data, as well as a NOAA chart that we're producing. On this product side, we're not actually making any edits to our geometry or attributes, but we are making certain finishing touches. For instance, on our charting products, we might move the representations of the features while leaving the underlying geometry intact. All of our edits, again, happen on the NIS side. So any updates that are here can be synchronized to these geodatabases, and we can publish products from them. So we can export from this ENC Florida cell product database to produce an EN or ER file. And at that point, we can use some external software for S58 validation, as well as exporting our chart here and producing it for press operations. Another question that we sometimes get is, does the PLTS Nautical solution include a way to convert DNC data to ENC? This is a really good question. Currently, no, we don't have a way to convert DNC to ENC data. However, we are involved in many of the IHO working groups, one of them being the ENC and DNC harmonization work group. And our involvement with this work group can eventually lead to a solution that will be able to convert DNC to ENC data and vice versa. Another question is the creation of exchange sets supported with the Nautical solution? I didn't mention this earlier, but yes, the PLTS Nautical Exchange Set tool can package S57 ENC ER cells, EN and ER files, as well as related text and image files. It groups them together and packages them into exchange sets, which is what is typically used by mariners and transferred on board ships. Our last question that I'd like to address is, which ArcGIS license do I need to use the PLTS Nautical solution? An ArcInfo desktop license is needed for the PLTS Nautical solution to be fully functional, meaning if you want to do everything with ENC production and charting production that you've seen here, you're going to need an ArcGIS desktop license, an ArcInfo desktop license. On behalf of ESRI, I'd like to thank you for your time. We hope you will attend other seminars as well. Please see the What's Next page for information on other resources related to what's new in the PLTS Nautical 9.2 solution.